Good afternoon and welcome to the webinar. My name is Kurt Smith with Applied Pavement Technology, and I'll be serving as your host for today's webinar on sustainable pavement materials, which will be presented by a trio of speakers from the Federal Highway Administration, including Leslie McCarthy, Rick Meininger, and Tom Yu. This is part of a series of webinars on sustainability that were developed under the FHWA Sustainable Pavements program and covers all stages of the pavement life cycle. Before we get started, I want to mention just a few housekeeping items. This webinar is scheduled for a total of 1 hour, consisting of a 50-minute formal presentation and a 12-minute question and answer session. The questions will be answered at the end of the formal presentation, but you may submit your questions at any time during the presentation using the question box on your control panel. If you don't see the question box, you may need to click on the orange arrow icon on the control panel to display these settings. We will work to answer as many of the questions as we can within the time allotted, but for those questions that we do not get to, the panelists will provide responses to all attendees via email. A copy of the presentation used in today's webinar will be shared with all registrants via email, along with a link to the webinar recording once it is processed. And for collective reference, here is a list of acronyms that will be used throughout the webinar today, and these are also be established on each individual slides on which they are first introduced. So with that, I would now like to introduce Monica Yarado with FHWA, who will provide a quick look at FHWA's Sustainable Pavements program.
Good morning and good afternoon. I would like to welcome you all to our second out of 10 webinars for our webinar series. Our presenters for today will be Rick Meininger, Dr. Leslie McCarthy, and Tom Yu. For today's webinar, you will be receiving 1 PDH per webinar, and if you complete 8 out of the 10 webinars, you will receive a course completion certificate. The Federal Highway Administration Sustainable Pavement Program began in 2010 with a vision and mission to advance the knowledge and practice of designing, constructing, and maintaining more sustainable pavements through stakeholder engagement, education, and development of guidance and tools. The Federal Highway Administration Sustainability Ambassadors Group is a liaison with the Sustainable Pavements Program and the respective program areas to help promote the practice of designing, constructing, and maintaining more sustainable pavements. Our speakers for today are part of our Sustainability Ambassadors Group. What can we learn from today's presentation? The key takeaways for today will be key sustainability-related considerations for pavement materials and strategies to improve sustainability of these materials. We will also talk about, I'll give you a brief recap of our first webinar on sustainability. The first recap would be the definition of sustainability. This is the definition that was developed by the Sustainable Pavements Program, focusing on the benefits of sustainability, which include not only the economic, environmental, and social. As engineers within the transportation programs, we are usually focusing on the economic. Now we will look at benefits throughout the entire life cycle, focusing on environmental and social, and focusing on the triple bottom line. There are opportunities to improve sustainability throughout the pavement life cycle. Today's webinar focuses on the material production, and we will talk about some key sustainability-related considerations for pavement materials. The primary pavement materials are aggregates, asphalt, and binders. Asphalt binders and hydraulic cement. Sustainability considerations include extraction, processing, and transportation, or what is better known as gate to plant, mixture design, and plant operations. The recycled co-products and waste materials, RCWMs, commonly used in pavements are recycled materials from old pavements such as RAP, RCA, and other co-products such as binders, which are from other processes such as the petroleum industry, where we get binder as a co-product, asphalt binder. And we also are looking at waste materials, which were ordinarily go into landfills such as fly ash. And with that, I will get our first sustainability ambassador, Mr. Rick Menninger from Federal Highway Administration, Turner Fairbank Research Center.
Thank you, Monica, and I'm going to switch over to my screen and bring the slides up. For some reason I'm having problems doing that. Okay, I'm going to switch my, there we go. Okay, I'm Rick Meininger, and I work here at Turner Fairbank Highway Research Center, and I'm going to cover aggregate issues as they pertain to sustainable pavements, concerning the use and application of aggregates. And certainly the primary use in pavements are asphalt mixtures, and which are flexible pavements, and concrete mixtures, which are rigid pavements. And then we use a lot of aggregate materials in base and sub-base layers, and sometimes subgrade improvement. Aggregates are a relatively low cost, and in terms of unit mass or weight, relatively low environmental impact. But since we use such large quantities of aggregates in pavements, they are a significant consideration for sustainability and in environmental aspects. If we look at the amount of aggregate that's contained in asphalt mixtures and in concrete mixtures, this is a slide out of chapter 3 of the reference book, and you can see from the large black areas on both sides here that aggregates represent a fairly large volume of the mixtures in both asphalt and concrete. At least 80% in asphalt mixtures and about 2/3 in concrete mixtures. And the key message here, and this particular slide does come from chapter 3 in the reference book, and there are a lot of good discussion about aggregate sustainability in chapter 3. The main takeaway here is that high volumes of aggregates are used in pavements, and it's a very important component of both the cost and the quality of the pavement, as well as its environmental aspect. Recycled materials that are close by certainly can be considered as aggregates for pavements. And then sometimes we might blend in other local materials that could be blended with other high quality aggregates to make a quality mixture. But anytime we use recycled materials, we want to make sure we're maintaining the quality and service life of the pavement. That's very critical. Go to the next slide, slide 20. Some of the aggregate-specific sustainability considerations are energy consumption and emissions, fugitive dust, water consumption, land use issues, community impacts, aggregate source permits, and aggregate quality. Energy consumption comes in the processing of aggregates. Typically, crushed stone aggregates would require a little more energy since you're crushing aggregates, and typically crushed stone is processed dry, so there might be more of a dust problem. And generally, local and state agencies in their permits for aggregate operations require dust control considerations, which may be water mist sprays or other dust collection devices. Sand and gravel quite often are processed wet, and dust may not be as much of a problem for that. But dust could be an issue with both transportation and use of aggregates. Sand and gravel is mined quite often either near rivers, on riverbanks, or even out of rivers themselves. So quite often there may be a change in the flow or course of a river, and that needs to be considered in terms of environmental considerations, and typically a permit would be needed for that. In terms of crushed stone, typically it's a quarry, and when sand and gravel and crushed stone operations are depleted, typically there would be a mine reclamation plan. Often there might be a lake involved, or a park, or a development that uses the natural aspects of the site. Community impact, certainly noise and vibration from mining and crushing. Typically, aggregate operations will try to establish a perimeter around, and the other community issue is the trucking or transporting of aggregates. And certainly that's an issue that needs to be addressed in terms of truck routes and best practices in terms of safety. New aggregate sources quite often are further away from urban areas because as the suburbs develop and the urban area develops, older mining operations generally are phased out. So transportation and use of best practices in moving the aggregate, trying to reduce the amount of energy. This slide 21, shows that trucking aggregates long distances is very energy inefficient. It also tends to beat up the pavements because we're applying additional easels on the pavement as we go along. Certainly rail and barging of aggregates on the inland waterways are preferred, and so generally trucking if the aggregates are close by. If they're further away, use of rail and barges is better. If we go on to slide 22, it talks about sustainability trends. For some reason, my slides are not changing. Let me try this. There we go. Current aggregate sustainability trends. We're tending to use more reclaimed asphalt pavement wrap in asphalt pavements, sometimes in bases. Recycled concrete aggregates quite often are used as granular bases under pavements. In the Houston area, for example, there's a great deal of crushing of concrete, which is used either as granular base or cement treated base. And there has been some use of recycled concrete aggregate back as aggregate in concrete. Some of the other co-products, for example, that are used as aggregate are blast furnace slag aggregates and steel furnace slag aggregates, and foundry sand sometimes can be used as well. The pictures on the bottom of the slide on the left show a wrapped stockpile of crushed asphalt or milled asphalt. In the middle, we have blast furnace slag, air-cooled blast furnace slag. On the right is a slag operation where they're dumping molten slag in a pit. It's then cooled with water and then crushed and screened to make aggregate. What are some of the sustainability improving strategies related to aggregates? I'll discuss briefly two of them. One is to reduce the amount of virgin aggregate used in the pavement, use more recycled materials, which tends to improve in terms of economic. Those recycled materials may be less expensive, and in terms of environmental aspects, it also makes use of a material that might otherwise just be in a pile somewhere or a landfill. Also, another strategy for reducing virgin aggregates is to try and use more durable aggregates or have the pavement last longer, in which case there'll be less cycles of having to rebuild pavements or rehabilitate it. So using more durable aggregates, making sure that the aggregates meet specifications and the mixtures are durable is important. Strategy number 2 is to reduce the amount of virgin aggregate and virgin aggregate acquisition and processing impact. Now here, review of environmental impacts of various aggregate sources. Sometimes in more rural areas or out west, there may be an aggregate pit nearby that can be developed. In other cases, there may be recycled materials that could be used that are convenient and will produce a quality pavement. Aggregate should be processed so it uses energy and water efficiently, and that crushing operations can be optimized so that there's a minimum of waste. Quite often, aggregate plants will make a variety of different products. Some will go into pavements, some may go into other uses. Future direction and emerging technologies, the proximity of aggregate sources to urban centers is certainly one of the things that's changing. Aggregate mining operations are tending to move further away, so this increases the pressures for using more and more recycled materials, and also increased use of maybe closer in marginal materials that were passed over in the past. And sometimes demand for specialty aggregates to meet specific goals is another emerging technology, perhaps for color of the pavement or friction or texture. Maybe the bulk of the pavement could be made with local materials, but there might be a demand to bring in aggregates from further away to meet specific criteria. Now I'm going to turn the webinar over to the next presenter, Leslie McCarthy. Dr. McCarthy was an associate professor in civil engineering at Villanova University from 2009 to 2019, and she recently rejoined Federal Highway in the Office of Pre-Construction, Construction, and Pavements at headquarters downtown Washington, and she's the senior asphalt pavement engineer that's heading up the recently revamped Mobile Asphalt Technology Center, MATC. So I'm going to turn it over to Leslie.
Good afternoon, everyone, and welcome to the asphalt portion of today's webinar. Asphalt materials are used in a number of different applications. Asphalt mixtures can include dense graded hot mix asphalt and dense graded warm mix asphalt. Warm mix asphalt we define in this webinar as a product that has additives to reduce temperatures needed for mixing and compaction. We also use open and gap graded hot mix asphalt in porous surface courses to reduce wet weather accidents and splash and spray. And stone matrix asphalt is a mix design that provides a very strong rutting resistant mixture. We talked a little bit about recycled waste materials, and those include in asphalt, reclaimed asphalt pavement or RAP, and recycled asphalt shingles or RAS. We also see in some parts of the country ground tire rubber is used and added to at the mixture phase. And asphalt products are used extensively in pavement preservation and rehabilitation. There are several key environmental, economic, and societal issues regarding the use of asphalt and asphalt mixtures. We know that asphalt prices are tied to some degree to the price of oil, which has fluctuated considerably over the last decade. In addition, the availability of asphalt binder and good quality asphalt binder is uncertain as refiners continue to modify their processes to produce more fuel at the expense of the binder. So that introduces some uncertainty in the future. It's anticipated that there will be increasing use of polymers and terminal blended rubber modified binders. So we'll need to accommodate these in design and construction, as well as the introduction of biobinders that may start seeing increased use. As I mentioned, the use of recycled content and waste materials is increasing, and there's a need to identify what the life cycle impacts are of adding those materials into your asphalt mixtures. This includes determining the proper quantities, the impact on performance, which is very important, in addition to future recyclability. How many times can you recycle materials that have RCWMS in them? In terms of current trends with asphalt sustainability, we're seeing that in asphalt paving technology, there's greater use of warm mix asphalt, not always at reduced temperatures, but for the impact of increased compaction, and also the incorporation of reclaimed asphalt pavement. So as warm mix asphalt use continues to grow, we see really three different types of technologies that are used to produce that: foaming with water, organic additives, and chemical additives. And so many asphalt plants have had to make alterations to their equipment and make some attempt at reducing their mixing temperatures. But again, more often than not, industry is able to use warm mix additives as a compaction aid to get density in the field, which is very important and has a positive impact. Increasing amounts of asphalt binder will be replaced by binder from reclaimed asphalt pavement. For RAP, that's really the highest use, as the binder recovered from the RAP replaces some of the virgin binder. A few agencies have been exploring the use of recycled asphalt shingles, or RAS, but there's some concern about the hardness of the binder in the mix that is produced with RAS. So questions of durability and long-term performance are things that our field really need to consider. Stone matrix aggregate is seeing increased use for rutting resistance, and there's some states that are just starting and trying to use this type of mix design, and other states that have been using it for a long time and seek to continually improve it. And finally, it's common to use thin asphalt surfaces to improve serviceability, both in terms of friction and in noise, and even aesthetics of the pavement, including placement on some new concrete that's common in Arizona and southern Nevada, for example. So as I mentioned, RAP will continue to, the use has continued to increase over the last decade. This slide here with the different colors, the blue shows you how much RAP has been used over the last decade in hot mix or warm mix asphalt mix designs. We also see it used as aggregate, which is the red trend. Green shows the use in cold mix, patching and other things. maybe other types of applications for RAP, could be geotechnical backfill and things like that. And luckily, that little blue line is the amount that's landfilled. And so, we see not a lot of landfilling occurring, which is a positive thing. And these are information that come from the annual survey conducted by the National Asphalt Paving Association. This is a figure here, also provided by the National Asphalt Paving Association, that shows the estimated warm mix usage. And this is also almost the last decade. We've seen steady increased use of warm mix additives. Again, the key immediate benefits of producing warm mix is a reduction in energy consumption required by burning fuels to heat traditional hot mix asphalt to temperatures in excess of 300 degrees Fahrenheit at the production plant. So, as you see in terms of the state DOT's of steep increase in its use, that's the blue trend, kind of topped off about 5 years ago. But another thing that's important to notice here is there's also an increase of warm mix being used in commercial residential construction as well as by our local agencies. That's the green trend that you're looking at there. So what are some sustainability improving strategies related to asphalt materials? Well, first strategy here is to consider reducing the amount of virgin binder and virgin aggregate content in your mixes. Reducing the asphalt use of the pavement life cycle has significant benefits, which can be achieved in a number of ways, including increasing the use of recycled content waste materials. Big thing to remember here is using these as replacement to virgin materials can have benefits as long as we don't unnecessarily increase your transportation haul distances and that we don't have a reduction in performance. So we want to make sure that our asphalt is performing at equal or better. So really got to look at that as a strong consideration that you're not compromising performance of your asphalt mix. A good example of this was the Illinois tollway. The tollway used 40 to 60% binder replacement in asphalt pavements using fine fractionated reclaimed asphalt pavement. Fractionated RAP is where they split the stockpile RAP between coarse and fine fraction. Another strategy is to try and reduce the amount of energy used both at the plant and during construction, and reducing the emissions as well. And so this shows you some tactics to be able to do that, such as using warm mix asphalt and to reduce the mixing temperatures, to actually using it with a temperature reduction, which there are a number of contractors that do that. Changing fuel used for heating, so perhaps changing over to natural gas. That's something to consider at the asphalt plant. Increase the efficiency of plants. That might mean updating some equipment or using some more efficient means, and also combining the use of warm mix asphalt and RAP, and that's been successfully done in a number of state DOTs. Third strategy that we'll mention today is extending the life of asphalt materials and reducing the transportation impact. So if you're improving compaction, you're getting a longer life, you're improving your mix designs, getting some indication of performance ahead of time, or even conducting more sophisticated performance tests, or using some modifiers such as lime liquid anti-strip. Some states require liquid anti-strip anytime a warm mix asphalt is used. So, these are different strategies that you can use to try and help get better performance and extend the life of your asphalt pavement. In terms of future directions and emerging technologies, we look ahead to what lies in the future for asphalt materials. We can extend asphalt pavement life through improved mix design and construction practices, introducing new materials, and increasing the use of polymers, rubber, and other modifiers where justified. Keeping in mind, you've got to make sure that it's not going to decrease your performance in terms of your service life. Keeping that in mind also, increased use of recycled content waste materials, especially RAP, where you can ensure equal performance. Taking advantage of using locally available materials, provided that the benefits are not offset by reduced performance. And keep an eye on bio-based binders. Their use is emerging. They're still in probably what we consider more of an experimental stage as opposed to implementation stage. They'd likely be blended with asphalt, but a full analysis really would need to be done to those agencies and industry partners that are considering to use this so we could try and determine the life cycle impacts. So that would be key in terms of thinking about using alternative binders. With that, I'd like to introduce our next presenter, Tom Yu from the Office of Infrastructure. He is the Pavement Design Program Manager in the Office of Infrastructure in Washington, D.C. He joined Federal Highway in December 2007 after working a number of years at the U.S. Army Corps of Engineers and many, many years as a consultant in doing pavement design and other pavement engineering. Tom was a member of the research team that developed the Mechanistic Empirical Pavement Design Guide. With that, I'd like to turn it over to Tom.
Thank you very much, Leslie. Okay, let me need to share my screen. So what about cement, hydraulic cement materials? There are many uses of hydraulic cement in pavements. For example, there are many different types of concrete pavements, including roller compacted and pervious concrete. And cement is also used in subgrade stabilization. And cement has a large environmental impact, even in small volumes, and we use a lot of it. You might be surprised to know that after water, hydraulic cement is mankind's most commonly used material. 1 cubic yard per year is produced for every person on the planet. So we do use a lot of it. So what kind of sustainability implications does hydraulic cement have? Mainly because cement production is such a high energy intensive process, and it also produces a lot of greenhouse gases. The main thing to do with concrete is reducing the cement content. So Portland cement production is such an energy intensive process. 74% of energy used and 81% of greenhouse gas associated with cement and concrete industry is associated with cement production itself. So the key to reducing the carbon footprint is reducing the use of cement. And we can also reduce water use. And key to reducing the cement use is using increased use of supplementary cementitious materials. And we can also improve sustainability by using more recycled waste materials like recycled concrete and things like fly ash. We could consider that a waste material. But all of this won't matter if we compromise durability. So concrete durability is always something to consider whenever we're considering sustainability impacts. So concrete trends in the U.S. There's been steady increase in use of recycled materials and supplementary cementitious materials, and there's increased use of Portland limestone cement and other blended cements. And the use of optimized aggregate gradation is in commonplace. And all these things actually are done to improve the long-term durability of concrete. So for concrete, improving performance, durability goes hand in hand with improving sustainability. So for concrete, sustainability, this is a win-win situation for concrete in improving sustainability and improving performance. So everything that we do for performance engineered mixtures for concrete also it helps to improve sustainability. So this shows the fly ash utilization. We know that the supply of fly ash is diminishing, is declining because of more stringent environmental rules. But the proportion of the fly ash use has been increasing steadily. So with the reducing supply and increasing use, as you can see, this can be a problem, and this is something to consider in the future. For slag cement, There's been a little drop in the early mid 2000s, but since 2008, the use of slag cement has been increasing steadily. So, what are some of the sustainability improving strategies related to concrete materials? This slide, if you look at this as end user for most of us, you might look at this. Well, this has mostly to do with the cement plants. What does that have to do with me? But again, because cement itself is so energy intensive and also it produces so much greenhouse gas, anything we can do to actually reduce the cement content helps to improve sustainability. So you might look at product information form to select the plant, the cement that's produced from more efficient plant, but also you could look at the content itself. Um, the ash, so what we normally consider regular cement, which is specified by ASHTO M85, it allows up to a 5% replacement with a ground limestone, another 5% inorganic materials, which is often slag cement, and also another additional 1% inorganic material. So normal cement can contain up to about 10% replacement material, which can be significant. You might the cement production itself is inherently uh, aggressive in terms of producing greenhouse gases, because more than half of the 50% of greenhouse gas emissions from cement production is actually inherent to the production itself, because the process involves converting limestone into lime, and what happens is limestone, which is uh, calcium carbonate, producing lime uh, produces carbon dioxide as a byproduct, and that amounts to about 50% of greenhouse gas produced in the productions. And there's nothing we can do to improve that. So as long as we use cement, this is inherent part of using that product. So as a pavement engineer, what we can do is again reduce the cement content by reducing the cement content, using more blended cement, using more supplementary cementitious materials, and also optimizing our aggregate gradation, which would help us reduce both cement content as well as reducing the water to cement ratio, because we could have more workable mix. The water use is again another consideration. We can use recycled washout water, recycled water used to process aggregates. And going back to the previous slide, just reducing the lowering the water to cementitious material itself can result in very significant reduction in use of water. In one case study we looked at, in a small, relatively small 6 mile project, by reducing the water to cement ratio and increasing the use of, they were able to reduce the amount of water used by 500,000 gallons on that one project alone. So the savings can be significant. Okay. Also, we can modify specifications to encourage more appropriate use of recycled waste materials, such as recycled concrete, using that as an aggregate, for example, using, say, for example, two lift pavements to allow using less durable material in the underlying layer and thinner surface layer for more durable material. Um, Okay. And we need to we can improve durability of concrete. Uh, and all the things, as I mentioned before, all the things that we do to improve sustainability helps to improve durability. So again, this is a win-win situation. Um, so what are the future directions in emerging technologies? EPA rules on emissions is impacting cement production. is affecting the availability of fly ash, and the slag production is more or less steady. So the natural pozzolans may become more important in the future. So even as we're trying to use more supplementary cementitious materials, this is becoming more challenging. And other things we can consider for sustainability are using something like photocatalytic cements that could be used to improve air quality, and low carbon and carbon sequestering cements could also be used to, uh, to reduce carbon footprint. Okay, so with that, I'll turn it over to Monica.
Other materials that we did not talk about today, but it could also be pavement materials and sustainability, are those of, there it is, such as steel, fibers, other urban environments such as interlocking concrete pavers or surfaces and bases that permit utility repairs, geosynthetics, and soil modifiers and stabilizers. So we will keep working on these and including other materials into our webinars and our tools as part of our Sustainable Pavements program. In summary, today the main takeaway was how material selection is important to sustainability, considering some of the trade-offs over the life cycle. Transporting materials has a major impact, and also some of the chemical additives used, even in small quantities, may have a large impact. So those were the key takeaways for today's webinar. Other products that we have through the Sustainable Pavements program are towards Sustainable Pavement Systems Pavement Life Cycle Assessment Framework, and other technical briefs. We have webinars from the past, the webinars from this series, and then we also have the roadmap, and they will all be hosted in our website. And to learn more, we expect to see you all in our next webinar, which is Design Approaches and Sustainability, which would be held December 19. For more information, please visit our website, and please feel free to contact Heather Dilla or myself. And with that, we'll open up for questions, and we also have 2 poll questions that we'll have open during the question and answer part. And with that, I'll turn it over to Kirk.
Thanks, Monica. And I think we will do the poll. We have 2 poll questions we'd like everyone to weigh in on, please. This is the first one, and we would like to have you answer whether you visited the Sustainable Pavements Program webpage. All right, thank you. And the results were shown quickly, and we'll summarize those results as well as part of the final products. Now we have a second poll question we would like you to answer, and we'll take about 15 or 20 seconds for this. How did you hear about the webinar? Please select all that apply. All right, very good. Thank you. We appreciate your time to fill that out. That will be helpful to us as we continue to move on through the series of webinar presentations. So now let's take a few minutes, and for the remaining time, let's walk through some of the questions. I appreciate everyone taking the time to ask the questions. We've got quite a few. We won't be able to get through all of them, but we'll see how many we can get through in the time available. To begin with, seems like there was just maybe some general questions or some general confusion maybe about some of the terminology. So I think I'm going to first turn it to Leslie and ask Leslie if maybe you could spend just a minute or two defining a few different terms, including binders, what exactly we mean by binders, what we mean by bio binders, and also what exactly RAP is, reclaimed asphalt pavement.
Sure. Yes. Well, let me say, sometimes the easiest way to explain in lay terms what binder is, if you think about baking cookies, okay, you would have your aggregates, which are like your chocolate chips, and your fine aggregates would be like your sugar. Your binder is really the combination of a little bit of the flour, but it'll be your butter or something that creates that sticky binding material. Okay, so binder it's a bituminous product from the fossil fuel distillation process. Okay, and so it's oil-based product, and it's what makes asphalt look black. So it's the material that binds all of those stones together. A bio binder as an alternative binder could include other types of materials like some sort of ethanol from the corn. Bio binders might include things like coming from corn or from other types of waste type products. So those are some examples, but there may be more information in the Sustainable Pavements website or guide that might talk about that as well. RAP is reclaimed asphalt pavement, and you can think of that as black rock. So what they do is they break up and mill up the asphalt as it exists on the road, and then they take that back to a contractor's plant, and they stockpile it, a big pile of it there. And then what they do is they crush that and they screen it, which is like sieving it. Like if you go to the beach, you use sand, you sieve that out, and then they can take that and they could actually use that as part of a replacement of natural rock that you would get from a quarry. Okay, so. And I think there was another question about how much RAP is typical, and it depends on the state. Each state has different specifications for their maximum amount of reclaimed asphalt pavement, but I think in the AASHTO guide for construction specifications, it's about 20%. But some states do use more. Some states even up to 50% they've tried, and some states may only use about 15%. So it does vary.
All right, excellent. Thank you, Leslie. You anticipated my follow-up question, so very good.
Great.
Let's move on. I've got a question for Rick. Whether we know of how many new sources or aggregates are being located from a historic perspective relative to sites that are being depleted. I don't know, Rick, if that's something you have any information on.
I really don't, but the U.S. Geological Survey has a specialist in both sand and gravel and crushed stone, and they actually have all the deposits sort of mapped out, and there would probably be a difference between, active aggregate production versus, some pits or roadside pits that might be used occasionally. Some of the more rural states, and I know Ontario has, it's a very big province, and they have many kind of roadside aggregate operations that you would bring portable crushers into and screens to make an aggregate product. But in general, and a crushed stone quarry, might have a life of 30, 40, 50 years. But when they try to expand expand their source, they really can't because development has encroached on the resource.
All right, very good, thank you. Let's move on to a question for Tom, whether there are any agencies that you're aware of that have any specifications related to carbon sequestering cements?
Maybe Monica would know more about this. I'm not aware of one.
Monica, anything from your perspective?
Can you repeat the question again? Sorry.
Whether there were any agencies that currently have active specifications on carbon sequestering cements?
This is Rick Meininger. We have done research on alternative cements, and some of these do sequester carbon dioxide, but they're really in the initial stage of use and mostly in precast products, small precast products.
This is Heather.
Looking back, I don't think. Oh, sorry. I was going to say, looking back, there's not.
Okay.
Go ahead, Heather.
Monica. I was going to add that as far as cement, as it cures, that there is a carbonation process where CO2 is through the lifespan captured in the concrete as it cures over time. And in the LCA framework that FHWA has, it does discuss that, but that occurs over the lifespan of the concrete itself. Then in addition, I am aware of companies researching how they can make the cement and use carbon dioxide as well in that capturing, somehow in the manufacturing process to help capture some of the CO2, but I'm not aware of that being deployable ready yet, more in the research phases, smaller startup firms and some interest in researching it. So I can't explain the details of it, but I'm aware of, and I think it's like Carbon Cure, some of these cements that are coming on the market, and that the cement industry as a whole is really actively looking into this and in new technologies.
All right. Thank you, Heather. Tom, we'll throw another one towards you related to whether anyone has seen reduced concrete pavement performance related to the use of lower cement contents over time.
I think in general, we've been using too much cement, and I think a lot of the work that was done at CP Tech Center shows that we can reduce the cement content. In general, significantly, and still get actually improve performance.
Right, and I think that question is really kind of hits at the heart of what we're talking about in a lot of these things related to sustainability. We talk about a lot of these different strategies that we can do to try to improve or increase the sustainability of a particular material or product, but the underlying premise generally is that we must see the same or better level of performance. So if we are making any of these particular changes for an environmental or a sustainability reason, we still need to be ensuring that we're not compromising or sacrificing the performance of our product at all. Let's move on a little bit. There was a general question about being able to calculate some of the different impacts related to making some of these different material changes or decisions, and just whether there's a way to look at that. Heather, maybe that's something you could address. Is there a way to look at these environmental impacts?
Yeah, so the assessment that is best to use to assess the environmental impact is the life cycle assessment methodology. And that was briefly mentioned in the introductory session, and we'll actually have 2 modules that focus in on the life cycle assessment. It is quite an intensive process, but it looks at all the environment or other inputs and materials used and energy used for the manufacturing of given products, and then all the outputs being your emissions, waste, and products, and tallies those throughout the whole life cycle of that product. So it follows it through when it's in the use phase and then disposed of, and then ties it to various impact indicators for environmental performance. And so one of them is global warming. Then there's also eutrophication, acidification, just to give you the flavor of the few of them. FHWA is working on a tool to help facilitate DOTs in assessing materials as well as pavement design. But we're not expecting that tool's not going to be out for another year or so. We're still in the process of working on that. But like I said, there will be a webinar that goes into the nitty-gritty details of life cycle assessment and what tools are out there and what's the best practices in doing so to evaluate the environmental performance.
All right, thank you, Heather. Another question, and I think I may have all the speakers weigh in on this one. Maybe start with Rick, and then Tom and Leslie, maybe you can weigh in as we go through this. There's a question about the use of fly ash in pavements, and maybe each speaker could comment a little bit on the applicability of fly ash as it fits into a pavement structure, either in the surface layer or in any of the base or sub-base layers.
This is Rick Meininger. Certainly fly ash is a very desirable ingredient in Portland cement concrete because it allows the reduction of cement content. It also sort of extends the strength gaining period. And if there is concern about alkali aggregate reactivity, the use of supplementary cementitious materials such as fly ash certainly helps reduce the amount of alkali that could potentially react with the aggregate. I think fly ash can be used as a filler in asphalt, is sometimes used in embankments. I don't think it's used in granular base courses, but it might be used in a cement treated base where you might use both cement and fly ash, maybe a class C fly ash that would set up.
All right, Leslie, anything to add from your perspective?
Yes, I do. One place where we could see fly ash use would be, and somebody asked about this on the questions about when is there 100% wrap that's used, right? Something like that. And we do have that in the situation of full depth reclamation of asphalt pavements, and I believe that will be in a subsequent webinar that you'll learn more in detail about that. But in full depth reclamation, you're basically recycling right in place. So you're recycling the asphalt pavement that's right already there on site, and you're reusing it right at the same time. However, sometimes if you've got other types of problems or just a less stiff soil, natural subgrade there, what they'll do is during the full depth reclamation process, they may add different types of materials, but fly ash is one of those, to act as a stabilizer and really try to make sure that this new base, if you will, is going to be strong to overcome any type of weaknesses that may be below in that existing pavement. And then they'll overlay that with a new asphalt mix. So, but one thing to keep in mind is if we don't have a lot of coal production, we don't have a lot of fly ash. So the use of fly ash is also dependent on its how much of it there really is for us to use.
Great, thank you, Leslie. Tom, anything to add from your perspective?
No, I think Rick covered it very well. I don't really have anything more to say, add to that.
All right, very good. Maybe down quickly to our last question, just kind of following up a little bit on some of the use of binders. I'll direct this one to Leslie. There was a question whether there's been much use of geopolymer binders in any base stabilization or full depth reclamation. Leslie, any comment or feedback on that?
So geopolymer, I'm trying to understand exactly what the person who asked the question means by geopolymer. There's certainly some types of asphalt binder-esque type additives that can be used, and my guess is this will be covered a little bit more in detail in a future webinar on maintenance and rehabilitation. But there's probably about 6-7 different additives that you can use, and I know kind of binder-based ones are one of those. So I'm sorry I can't provide more information, but if someone could explain a little bit more what they mean by geo binders, it might be able to help out.
Right, and I think you're right. I think that is kind of an expanding area. I mean, for years, obviously, we've used the traditional stabilizers, but it does seem like there's been some work looking at some of these newer products and newer materials. So I think we're going to have to close it off right there. We are up against our time limit. Appreciate everyone submitting the questions. Again, we will have each of the speakers will go through the questions, and we'll develop answers to these questions and make those answers available to everyone. So with that, again, I'd like to thank everyone for your time and attention, and we certainly hope you found the webinar informative, and look forward to having you attend our next webinar, which is scheduled for December 19th. So thanks again, and best wishes for a good day. So long now.